Have you ever wondered about how a 90s video game, classic computer processors, choked trying to calculate millions of 3D polygons? So, engineers designed a specialized chip to handle math simultaneously. They branded this new powerhouse chip the very first GPU. Unlike CPUs, it split giant calculations into thousands of tiny streams. Think of it as hiring thousands of toddlers to finger paint. This parallel processing made virtual worlds look incredibly realistic. But beneath the video game, monsters lay pure matrix multiplication. Coincidentally, this exact math is what neural networks crave. A toy designed for teenagers accidentally built the AI foundation. Developers hit a wall trying to render complex 3D worlds. They realized calculating thousands of pixels simultaneously required massive parallel power. Engineers built the graphics processing unit specifically for these visual tasks. These chips were basically giant calculators for solving linear algebra equations. Nobody suspected this gaming tech would soon define modern machine learning. Training neural networks involves the exact same type of matrix math. It is funny how a digital plumber accidentally built a brain. GPUs handle millions of tiny operations faster than any standard CPU. This massive throughput finally made training deep learning models actually feasible. The graphics chip became the engine for the entire AI revolution. Engineers realized these 3D chips could handle thousands of calculations. Instead of one task, they processed millions of pixels simultaneously. Artificial intelligence researchers suddenly found the perfect hardware for training. NVIDIA shifted focus toward research labs needing raw computing power. Their software platform let scientists talk directly to the hardware. Models that took months now finished in just a week. It is funny how rendering explosions helped us train brains. Massive datasets flooded these chips to refine pattern recognition accuracy. Every major lab scrambled to secure these specific gaming cards. This accidental synergy finally made modern large language models possible. Sony needed a chip to calculate millions of 3D triangles. It crunched math in parallel, unlike standard computer processors then. Researchers realized this gaming hardware could also accelerate complex math. NVIDIA saw the potential and built a software bridge, CUDA. Suddenly, programmers could run scientific code on cheap game cards. Machine learning models were trapped by slow, traditional CPU speeds. Neural networks are basically huge grids of numbers, or matrices. Multiplying those matrices is exactly what gaming chips do best. Game chips inadvertently provided the massive power AI models required. Engineers realized these 3D chips could handle thousands of calculations. Unlike standard CPUs, these cards processed massive data sets simultaneously. A new software layer let programmers finally bypass gaming graphics. Neural networks are essentially just giant, complex grids of numbers. Training models once took months, but GPUs cut that drastically. It is funny how a simple gaming toy changed science. With enough raw power, machines began recognizing images and speech. Researchers stacked thousands of these cards to build massive clusters. This hardware shift provided the engine for today's generative models. Sony needed a powerful graphics chip for their new console. This chip excelled at crunching thousands of pixels simultaneously every frame. Engineers realized that rendering 3D worlds required massive matrix multiplication math. Turns out, modern neural networks use that exact same math. Video games were just the training ground for massive computation. Hit the subscribe button and press the bell icon to get updates. NVIDIA rebranded these gaming chips as versatile tools for scientists. Suddenly, researchers had the hardware to process infinite training data. A simple toy chip actually powered the entire AI revolution. Sony designed the PlayStation chip to render simple 3D polygons. They built it to calculate thousands of pixels simultaneously every frame. Engineers realized this parallel math works perfectly for training neural networks. AI models effectively live inside massive matrices of numbers requiring speed. Gaming hardware provided the raw horsepower that CPUs simply lacked then. NVIDIA wisely leaned into this unexpected demand for heavy computation power. Connecting thousands of these chips together created the modern AI laboratory. It is funny how Lara Croft helped build the machine mind. Without cheap gaming silicon, the current AI boom would stall. NVIDIA realized their gaming chips could calculate massive parallel equations. Instead of one task, the GPU tackled thousands simultaneously today. They released CUDA, letting programmers use these chips for math. AI researchers suddenly had the hardware to train deep networks. Massive datasets were finally processed in mere hours, not weeks. It is funny how rendering a dragon helped build intelligence. The chips got faster, allowing models to grow incredibly large. Today, those same gaming architectures power the world's smartest systems. We owe the current AI boom to 90s graphics chips.